Alright everyone, so we've set up a test today to show you the capabilities and the performance of the DCS 12 volt 80 amp hour extreme range of batteries. Okay, now unlike our blue deep cycle range, okay, that it's been on the market now for over 5 years, this is a product we released recently in direct response into a demand for be able to charge your very high power alternators, to be able to use high-powered winches, naval and military applications where extreme cold cranking amps at sub -20 degree temperatures are required, etc. Okay, so this is an N70 12 volt 80 amp hour battery. Okay, it has a full operating range from -20 degrees Celsius through to 80 degrees Celsius. It is suitable for under-bonnet applications. Okay, that is what it's designed for. Alright, just to go over a couple of specs here. So it's a heavy-duty LiPo4 battery cell technology. Okay, so lithium iron phosphate. It is different to our deep cycle range. Our deep cycle range of cells are specifically optimized for deep cycle applications, such as caravans and boats. This is a heavy-duty cell that is engineered for very high discharge currents. Okay, so it will give you 2,000. It will give you over 2,000 cycles, charged and discharged at around 200 amps. Okay, so the cycle use there 11.5 to 14.6, the same as our other range. Suitable for alternator charging. Okay, max alternator output 200 amps. I mean, it's pretty hard to find an alternator that's over 200 amps, but virtually you can connect to any alternator you can dream of. Suitable for winching, okay, and we're running a very advanced microprocessor controlled BMS, okay, that has automatic over temperature recovery and automatic cell balancing, okay, and it manages cells at very high currents, and easily delivers over 1,000 cold cranking amps. Okay, so we've actually tested these. We're getting 1,400 cold cranking amps at 20% stated charge. All right, now, being a development and engineering company, product development type company, we say that these are designed for 200 amps continuous, okay? But we're actually going to prove to you and test today that they'll run comfortably at 250, 260 amps all day long, all right? So what we've set up here, okay, is a little test bench, all right? Now we're running two of the DCS 12 volt 60 amp chargers. All right, so running two of those in parallel to give us 120 amps of charging power. All right, and you can see that battery is currently sitting at full charge. Okay, so they've both gone through to full charge. All right, running the 3,000 watt pure sine wave DCS inverter. Now again, you'll notice it says continuous output. The DCS 3 kilowatt inverters are designed for just that. They will run at 3 kilowatts all day long. That's what they're designed to do. Twin variable fan high velocity fans, so they will ramp up and down depending on how much load you're running. So on a light load they won't even run. Once you get over a kilowatt they'll start to turn on, and at full pace at 3,000 watts they'll be running flat chat, and the inverter won't depower. It will give you that linear 3,000 watt output all day long. This inverter we're going to connect a 3,000 watt load to this inverter, which is around about 250 to 260 amps at 12 volts. Okay, so we're going to be running this guy at flat chat during the test, and then we're charging flat chat as soon as the battery's completely empty. Okay, we're recharging here at 120 amps. Okay, so discharging at 150, discharging at 250, and charging at 120 amps. All right, on a little tiny 10 kilo 80 amp hour battery pack. Okay, so what it's designed to do. So we're going to be measuring the current over here. Okay, and we're going to be looking at the battery voltage. So you get a resting voltage here at 14 volts, so we know it's fully charged. That's our buzz bar there. Everything's running. All right. So we're turning on the inverter. All right. So the inverter goes on, and now I'm going to go and turn on. Okay. So we got a standby current there at 14 volts of under 1 amp. All right. So that in itself is pretty impressive. Pulling less than 1 amp at 14 volts on standby. so they have a very low current draw on standby, which is excellent. And we're going to turn on 3000 watt load. All right, and we're pulling 260 amps. Okay. Obviously the voltage sitting there at 12.5 volts. You know, an 80 amp hour battery, okay, it's pulling 255 amps, all right, and it's still sitting well above 12 volts, okay. So you can see these heavy duty cells are optimized for very high discharge current. So at very high discharge currents, you're not pulling the voltages down, okay. So they'll sit above 12 volts for the majority of the test, all right, at such a huge 250 amp load, okay. So this inverter now is completely loaded up to maximum power. It's pulling 3000 watt. I've just got some electric heaters on, pulling 3 kilowatts, okay, at 240 volts, which is 260 amps, 250, 260 amps at 12 volts, okay, 12.4, all right. So we're going to let this run. Now I'll keep videoing until the fans come on, so you can actually see that it is loaded up. Okay, we're going to run this test all the way until the inverter shuts down, till the battery pack shuts down and gets completely empty. All right. So we're discharging an 80 amp hour battery from full charge to full empty at 250 amps. All right. The second that battery is empty, we're going to turn on the chargers, and we're going to top that battery back up at 120 amps. Okay. And that battery is designed to do that all day long. All right. So that's the point of this video, and that is what we are showing you today. Okay, so it's been about 10-12 minutes. Current's dropping now to 245 amps. Okay, and the voltage is still sitting pretty happy there at 12.27. So if you multiply that, we're still sitting at 3000 watts, okay, on the inverter. So both those fans are running there, just keeping that nice and cool. Let's start this. Okay. So we're just going to keep going, and 20 odd minutes, this battery is going to discharge at 80 amp hours in somewhere around about 20 minutes. Okay, so yeah, the terminals are still cool to touch, nothing wrong there. Obviously the cables are getting pretty hot, they're only 35mm cables, so running 260 amps is sort of double what they're designed to handle, but they're not crazy hot to touch either. So the buzz bars are nice and cool, so everything's running beautifully. The battery's not getting warm at all, it's sitting completely cool at ambient temperature. No heat in that at all, and like I said, the terminals are still nice and cold to touch. Okay, so 12.25 volts, 245 amps, so still sitting just above 3000 watts, and pulling this load comfortably. Battery will do this all day long. That's what it's designed for. Okay. So if you're looking for a quality winching battery, good luck trying to find anything as capable as this product, and the weight and the service life. Or even, if you're looking for a super reliable and durable battery for a boat, this battery will do it all. One battery, put it in, run all your equipment off it, crank your engines off it, leave it trickle charging on solo when you're not using the boat. Don't need 2 or 3 or 4 or 5 batteries. Single battery can do it all. Okay, so we're starting to drop a little bit now, 12.21. Across the terminals of the batteries, 243 amps. So we're coming up to the 20-minute mark now. The battery's probably sitting somewhere around 20 or 30% stated charge. Discharged 2/3 of its capacity already. Okay. And still sitting well above 12 volts. Okay. And again, I'll just pause it. I'll come back again in a couple of minutes when we're getting very close to emptying that battery. Okay, it's coming up to around about 25 minutes now. Still got a battery voltage of 12.08. Okay, it's getting close, pretty close to 12 volts now. And we're still pulling 240 amps, 239. Okay. Terminals, still not too hot. Okay, starting to warm up there a little bit, but no residual heat in around those terminals, so it's perfectly fine. 12.05 volts, 240 amps. Okay, these cables obviously getting pretty hot now as they're running twice what they're designed for, so we got a bit of voltage off through here. But surprisingly, the cables that we supply with the inverter are running quite cool, significantly cooler. So it is a very good quality copper that we're using with those cables. Okay. Inverter's still running without any problem. 3000 watts. Still relatively cool. I mean, probably 4 or 5 degrees above ambient. There's very little heat in that chassis. Cooling beautifully. Okay, so here we go. So we're just dropping below 12 volts now. And very close to emptying out the battery. Astonishing that a little 80 amp hour battery can do that. And do it all day long. So with the characteristics, a classic characteristic of lithium iron phosphate is that it gives you nice linear power delivery for upwards of 80%, nearly 90% of its charge and discharge curve. So you can see we're only just starting to taper off now. So 11.91 volts. 1.9, and now it's going to start dropping exponentially and quite quickly as that battery approaches 0% stated charge. Okay, so as it gets completely empty. Still pulling, so current slowly dropping away, 235 amps now. Right, and we'll just focus on the voltage here. It's 11.83 at 234 amps. Okay, so you can see it's starting to accelerate there, that voltage drop. Very little left, very little capacity left in this battery pack now. You are not doing any harm whatsoever to the battery cell or its lifespan or its service life. This cell chemistry is specifically designed to give you 100% depth of discharge. Okay. Yes, if you don't do 100%, if you do 90 or 80% DODs, it's going to last longer. Typically, a well-designed setup, you're only going to see 30 or 40% depth of discharge. So the cycle life is tremendous. But you can discharge this battery over 2,000 times, okay? At this very fast discharging current. At this very high discharging current. And you're not hurting it, okay? You'll see that as soon as this battery empties out in a minute, we will be supercharging it at 120 amps. So charging an 80 amp hour battery at 120 amps, okay? You can see the voltage really starting to drop off now quite quickly. Okay, the battery's nearly empty. Okay, the current's dropping off, the voltage is dropping off. The inverter will go to protection soon at around 10.5 volts. Between 10.5 and 11 volts, the inverter will shut down because that battery will be virtually empty. Okay, so voltage is dropping. The integrated circuit board now is just starting to change tone a little bit. There we go. There goes the alarm. Okay, and the inverter's shut down. Loads off. Inverter's off. Okay, we're sitting at 11 volts. Now, cycle voltage is 11.5 to 14.6. So we're well and truly under 11.5 and well and truly empty. Okay, so now instantly going to turn on both chargers. Alright. Okay, so now they're doing a test, 30 amps, so we're already charging at 60 as they test. And off they go at full power, so 60 amps on the top one, 60 amps on the bottom one, 12.1 volts. So now we're charging at 120 amps. Okay, and that voltage will start coming back up. Alright, now to show you that we are charging at 120 amps, we can see here 115 minus some losses in the cables in this bus bar. Alright, so 115. Okay, so now we're going to let this little battery fully charge. Alright, at 120 amps, back up to full capacity, and just showing you that we've done that all in you know, probably just over 30-40. I mean, it's going to be under an hour. Okay, you've discharged this battery at 260 amps and charge it back up at 120 amps in around about 60 minutes. Alright, and it's completely cool. Okay, that's what it's designed to do. Okay, so we've been charging now for 26 minutes. We've put 26 times 2, okay, so 52 amps back into the battery pack. So, you know, we're just over halfway there, around the 40-minute mark. We should be fully charged on 15 minutes, so still both chargers are cranking out at 60 amps, and we've got 119.2 amps going in. And the voltage is sort of sitting there at 13.73 volts now. So we're nearly there. The battery pack's obviously still nice and cool. There's no heat at all in those cells or from the battery management system. That is all super cool. And yeah, you know, a couple more minutes and we're back at full capacity, and you know, it's ready to go again at 260 amps all day long. That's what it's designed to do. Okay. We'll get back to you once we're fully charged. Okay, so getting pretty close here now. We've got 39 minutes, 39 and 39, so nearly 80 amp hours back into the battery. Obviously, plus some losses in the cables. They'll be offset by the chargers, so they'll start doing a stage 2 constant voltage charge, which they've already entered now. So I'll start tapering off the current, pack those cells right up, back to 14.6 volts, and we'll just have a quick look and see what the actual voltage here there is now. Yep, so 14.03, so nearly fully charged. So the chargers will ensure they'll pack those cells right back up to 14.6 volts. Okay, get back to another couple of seconds. Okay, so the current's reducing now. So 20 amps, tapering off. Battery voltage now is 14.48, so nearly fully charged. Okay. Terminals are completely cold. Just coming off 120 amp charge for 40 minutes. So 14.55, nearly there. We're running down to 4 amps here. Okay, so she's stopped charging there. And the beautiful thing about our charge is it tells you how long it charged for. So 41 minutes and 33 seconds. It's put exactly 41.0 amp hours out of the battery, out of the charger. Okay, and the top one's just going to finish off now. So it sort of takes over that last 10 amp voltage curve. And we're nearly there, 14.58, so virtually 99.99% charged. 14.59, down to 8 amps, so still packing those cells in there a little bit. 7.4 amps, 14.59, 14.6, we're just touching it, there we go. So 14.6 across the battery, so now it is at full voltage point. And still pushing 6 amps. 5.8. Now chargers are very precise and they'll go all the way down to half an amp and pack that battery pack all the way back in. So you can actually just hear now the fans have come off. So because of that, there we go. And we're fully packed up there. So 41.7 amp hours, 41 amp hours. So you know, virtually put 80 amp hours after losses back into that battery pack, and that voltage now has dropped down a little bit and go back to a resting voltage. And that completes the test, guys. So thank you very much for watching, and hoping you can appreciate what we've designed here in what is really truly a top performing compact and lightweight battery. And these are available now, they're in stock. If you've got any questions, guys, just send through an email. Any comments, questions, send it all through, and we're more than happy to help you. Thanks for watching.